Hello everyone, in this YouTube video I'm going to be talking about climate change. We have developed several tools in AP Microeconomics that will allow us to tell the story of climate change and potentially to think about the impact and the burdens of associated with policies aimed at either mitigating or addressing that problem of climate change. So let's get into this. So in Unit 6, we talked about market failures and the role of government in addressing market failures. And I'll talk a little bit more about market failures in a moment. Well, I guess I can talk about it now. But a market failure is a situation in which the market equilibrium doesn't maximize social welfare. And so before I get into talking about externalities, which is probably the model that I think a lot of you most associate climate change with, or probably associate climate change with, insofar as you associate, topics with models in microeconomics. But we said that markets have some special qualities, right? At the beginning of this course, especially in Unit 2, when we assumed perfectly competitive market setting, we said that we expect markets to produce the social welfare maximizing quantity, right? Leaving the market alone, again, absent market failures, and assuming perfect competition will produce the social welfare maximizing quantity, right? And so we can visualize it here, right? What we mean by social welfare in economics is we mean consumer and producer surplus, right? And there are limitations to that concept that I'm going to address in the income inequality video that I'm going to develop later today or tomorrow. But, right, this yellow area I'm going to use to represent consumer surplus, and then this blue area I'm going to use to represent producer surplus. And we said markets, absent market failures, right, and assuming perfect competition, will yield the social welfare maximizing quantity. We also said we should expect leaving the market to its own devices to get the allocatively efficient or to arrive at allocative efficiency. And what I mean by allocative efficiency is a situation where everybody that values this good or service, whatever it may be, at this particular price and higher is going to acquire it, right? We're not in allocative efficiency when people that value a good or service at a particular price are unable to obtain it. But we said leaving markets to their own devices, assuming perfect competition, assuming no other types of market failures, we arrive at allocative efficiency and we maximize social welfare, which we measure as consumer and producer surplus. Right? And then we did in Unit 2 all kinds of government interventions, and we saw how that negatively affected social welfare. It might have redistributed either producer or consumer surplus, but we ended up with deadweight loss, market transactions that didn't happen, that if we left the market alone would have happened. But markets can fail, and one type of failure is an externality, right? And an externality, which you can see the graphical representation of a negative production externality here, is a situation in which the cost or benefit imposed on a third party an externality is a cost or a benefit that is imposed on a third party that did not agree to incur the cost or the benefit, right? They arise in situations in which the parties engaged in a market transaction, so both producers and consumers, don't internalize all of the costs and benefits associated with that market transaction, right? And so a classic example of an externality is stuff like pollution, right? So for instance, we can think of this in terms of a production facility that has in its production process is dumping sludge down a river, right, and is killing a bunch of fish, right, and they're making, I don't know, steel, right? I'm still thinking of that international trade example that I developed in my international trade review topic video, so go check that out. And so obviously that those steel producers are not internalizing the cost associated with them dumping the sludge down the river, right? That's externalized, and someone else is bearing that cost. And so climate change, you can think of it as a giant externality, right? A situation in which individuals are burning fossil fuels, right? And they're not necessarily internalizing the cost of burning fossil fuels because they're just being released into the atmosphere. And those fuels are, greenhouse gases are dramatically accelerating or not dramatically, but those fossil fuels or this burning of fossil fuels are contributing to climate change. Right. And so the way that we graphically represent this, right, because this is a complicated story to tell, is that we show, right, this is a negative production externality. So this is a situation in which a production facility, let me see if I can get a different color. Let's see, this would be a negative production externality. So this might be a production facility that, or facilities that has within its production process the burning of fossil fuels, right? And it's not internalizing the cost with the burning of fossil fuels. We draw it as a gap between the social marginal cost curve, which is what this represents, and the private marginal cost curve, which is the supply curve, right? And then we have a demand curve here, and the demand we can see is equal to private marginal benefit and social marginal benefit. If there are no externalities present, then social or private marginal cost curve is equal to the social marginal cost curve, and all the beauty and power of markets exists, assuming perfect competition, right? And we maximize social welfare. But we can see here that we're not maximizing social welfare. Society, if we take into account the costs of the burning of fossil fuels, this would be reflecting the cost curve, right? And the supply curve that reflects the internalization of this burning of the fossil fuels into the atmosphere, right? And so we can see, right, and I always tell you, go to the x-axis first and go across to be able to tell a story, right? Because we can tell pretty sophisticated stories. We can see that at this point, at Q1, we're overproducing. Society would rather produce at Q2, but we're producing at Q1, right? And then we can actually draw a dead weight loss triangle, right, which reflects not market transactions that we would want to happen but don't happen, but in this case reflects market transactions that we don't want to happen but are taking place, right? If this was eliminated, we would be producing at the social welfare maximizing quantity, right? But this is taking place, right? Instead, we're overproducing. We're in a market failure. And so some policy solutions that can help rectify a market failure, right? There's a role for government intervention in this and forcing us to produce the social welfare maximizing quantity, which would be Q2. And what we would want to do is we want to shift this whole private marginal cost curve and close the gap between the social marginal cost curve and the private marginal cost curve. And so one way we could shift it to the left is institute a tax. And so I'll talk about gas taxes at the end of this video, but that's one way to sort of bridge this gap, right? So this was one of the most recent tools that we've developed. right? Externalities, which we said can tell rather sophisticated stories. And now I want to also show that externalities can be drawn many different ways. We can think of, the burning of fossil fuels and greenhouse gases as a consumption externality as well, as a negative consumption externality. And so I just want to show you this really quickly. So demand equals private marginal benefit. And then the social marginal benefit curve would be further to the left. And then our supply curve would equal private marginal cost and social marginal costs. And remember PQ, always label it. And if it helps, think of Priscilla Quintanilla, Miss PQ. Right, and this would be a case in which consumers are continuing to buy, vehicles that emit tons of greenhouse gases. Not Mr. Diaz. Mr. Diaz has a Nissan Sentra with eco mode. There's a long story behind why I have a Nissan Sentra with eco mode, but that's for another time. But we can see in this situation, this would be an example of a negative consumption externality, and we can tell a similar story, right, about over consumption in this case, right? Consumers that are buying those gas guzzling vehicles because of style, or they just like how they look, right? Or I guess in the United States, rather frequently, the refrain is, no one tells me what to do. I don't know, right? And we can see, right, we can visualize, right, this consumption of these gas guzzling vehicles, and we would prefer, as society, the social marginal benefit curve is further to the left, would prefer you to prefer the market to produce at Q2, or prefer consumers to produce or to consume at Q2, but instead they're consuming at Q1, right? And so we can actually draw a deadweight loss triangle. And the way that you can think of drawing deadweight loss triangles is you always want the arrowhead to point to the socially optimal quantity, right? And so, right, these market transactions are taking place, but the society would prefer they don't take place. But since people engaged in this private market are not internalizing the costs of buying this vehicle, right, it's externalized on everyone else that isn't purchasing this vehicle, we get overconsumption, right? So we can see this, right? We go to the x-axis and we can tell a story of overconsumption. And similarly, there's potentially room for government intervention in getting rid of the externality and the market failure. And so externalities are very, you can tell pretty sophisticated stories about climate change and using externality graphs, right? That's the whole point of why we use models and graphs in economics, because we can tell pretty sophisticated stories using models and graphs. And now we're actually going to use this game theoretic concept of the prisoner's dilemma, specifically, to tell an important story about climate change as well. So first, I wanted to say that the reason why remember, we introduced game theory in Unit 4 when we're talking about imperfectly competitive output markets. And we said game theory can help us, right, because it's kind of hard to draw a model of like oligopolistic competition, right? We could draw a graphical model of monopolistic competition, and I'll talk about monopolistic competition in my review topic video on pandemic economics. Or I'm sorry, not monopolistic competition, but the monopoly model in my review video on pandemic economics. But oligopolies, we said, we can think about oligopolies perhaps more effectively using game theory. And so in this class, because this is an introductory microeconomics class, we're always just going to have two players with two strategy sets, right? And so we can actually apply this, right, and this game theoretic concept in many different, or we can apply it differently, right? We don't have to use it to describe, oligopolistic firm behavior. we can use it to describe country behavior in terms of greenhouse gas emissions, right? And so we can do this. Let me see. Reduce, right? We can think of two strategy sets: greenhouse gas emissions. Ooh. Right, so we can think of two strategy sets for potentially two countries, right? Stay the course or reduce greenhouse gas emissions. Oh, and I just realized I probably should put this here and switch them, but I'm just going to leave it like this for now. I'll do that in the next game, right? Because we can still sort of see the intuition. Doesn't alter the intuition that we can develop, right? And we can think of two countries like the US and China. And then we also have to have payoffs, right? And so remember, the row player is going to be the first number, and then the column player is going to be the second number, right? And I'm going to say that these numbers are going to reflect utils, like the utility of particular courses of action. But we can also have like dollar payoffs too, so on and so forth. Let me see, -200. What is this? Stay the course 0, 0. Okay, and so this is a classic prisoner's dilemma, and we can see we said that with the prisoner's dilemma, it's a special type of 2x2 game that we can use to think about the inherent instability in oligopolistic markets. But in this case, we're going to apply it to climate change, right? So we have two countries, the US and China. And of course, right, this is not a very complicated game. Let me get my charger. This is not a very complicated game, and there's obviously more players in the climate change greenhouse gas emissions game than just two players, but we could still tell a very sophisticated story with just the simple 2x2 game. Right. And so to solve games, we have to first find dominant strategies. And as long as we have one dominant strategy, we can solve a game. Right. And so what we can do is we can physically cover up one strategy. So let's, for example, look for the what is the best response the US can play if China decides to reduce greenhouse gas emissions. So the best response would be to stay the course, right? So I'm going to circle 500, right? Because they get the most amount of utils if China decides to reduce greenhouse gas emissions, and the US gets to shirk the responsibilities of reducing greenhouse gas emissions and stay the course, right? And then finally, we can like physically cover up the China strategy, right? This was more effective when I had a whiteboard, right, of reducing greenhouse gas emissions, and assume that China is going to stay the course, right, meaning not reduce greenhouse gas emissions. What would be the US's best response to that? Well, we can see it would be to also stay the course. And so we can see that the US does in fact have a dominant strategy. And as long as we have one dominant strategy, then we can solve a game, because our expectation of the solution of the game would be the player that has a dominant strategy is going to play that dominant strategy, and I'll talk about what those dominant strategy means in a second, and the other player will just play the best response to that dominant strategy. But we're going to see also in a bit that China also has a dominant strategy too. What is a dominant strategy? It's a strategy that a player, for instance, the US, can deploy that would yield higher payoffs irrespective of the other strategy, or would yield higher payoffs compared to the other strategy that the US has, irrespective of what China plays. Wait, hold on. I think I'm messing up the idea of dominant strategy. Hold on. Sorry, y'all. It's just I haven't got enough coffee. Yeah, so it's Wikipedia. No, I shouldn't do Wikipedia. But it's this idea of when one strategy is better than another player's strategy, which is what I said, for one player, no matter what the other player plays, right? And so we can see that, right? We saw that if we assumed China did either of these strategies that are dominant, the strategy that the US would still pick, or the strategy that would yield the highest payoffs, is stay the course, right? So the US has a dominant strategy. And then finally, we'll see if China has a dominant strategy, but we only, since we expect the US to play their dominant strategy, the best response to the US playing the stay the course strategy would be the solution to the game, but we're also going to see if China has a dominant strategy. So let's cover up the US's option, and let's assume that the US decides to reduce greenhouse gas emissions. What would be China's best response? Well, China's best response would be to stay the course, right? Because they want to shirk the responsibility of reducing greenhouse gas emissions and just have the US do it. And then what would be China's best response if the US decides to stay the course? Well, it's stay the course. And then we can see that we've arrived at a solution to the game. So our expectation is that both players will play their dominant strategy, which is to stay the course. Right. So this is a popular solution concept. It's called the dominant strategy solution concept, but we don't need both players to have dominant strategies to solve the game. We would expect, as long as one player has a dominant strategy, the other player would just play the best response to the other player's dominant strategy. That's another way we can solve the game. And what we arrive at is we arrive at several things, right? We arrive at the third best outcome for both players, right? The first best outcome for the US would be, this box right here, where they get 500 utils, where they get to stay the course, and China has to reduce greenhouse gas emissions. The first best outcome for China would be in the bottom right-hand corner, where they get to stay the course and the US has to reduce greenhouse gas emissions. And then the worst outcome for both countries, respectively, are the best outcome for sort of either country, right? It's the reverse of the best outcome for the other country, if that even makes sense, but you guys get what I mean. And then the second best outcome right here, if they both decide to reduce greenhouse gas emissions, and actually I think this was supposed to be 200. Yeah. So imagine that this is positive 200 to get at this idea that this is the second best outcome for both players, right? Positive 200, positive 200. But they end up at a suboptimal outcome, right? The third best outcome for them, or the second worst outcome for both, right? 0, 0. And this is called the prisoner's dilemma, right? Because we can see the inherent instability to potentially an agreement to reduce greenhouse gas emissions, because there's this incentive to cheat, right? And this incentive to cheat is the same that dominates in oligopolistic markets, right? And forces or makes oligopolistic competition, even in instances of like collusion, inherently unstable, right? And so we arrive at a Nash equilibrium where there's #no regrets. There's no incentive to deviate, right? You can look at the other outcomes of the game, and then you would see that there would be incentives to deviate. For example, in the top left box, China would be like, if this was a game, they would be like, oh, dang, I really wish that I had decided to stay the course because the US didn't, right? And my payoff would have been larger. The reverse is true in the bottom right-hand corner. And then finally, in the top right-hand corner, both players have an incentive to deviate to achieve a higher payoff, right? So we can we can think about how the implications of this game would be, or how unstable sort of agreements potentially could be to, or agreements absent sort of, sanctions or some form of institutional mechanism of holding folks accountable, because there would be this sort of incentive to deviate, right, to pull us towards the Nash equilibrium. Because at this square right here, we can see that both players are playing their best response to the other, which is what a Nash equilibrium is, and there's hashtag no regrets, right? China doesn't wish, oh, dang, I really wish that I had reduced greenhouse gas emissions, because then they would have a negative utils, and the U.S. doesn't think, oh, dang, I really wish that I had reduced greenhouse gas emissions, because then they would have negative utils, right? So there's no regrets at the Nash equilibrium right here. Everyone see that? So we can use this awesome tool to tell us a story that is rather effective and impressive, I would add, or rather powerful. There are some that think that climate change, however, shouldn't be modeled as a prisoner's dilemma anymore, and I'll include a link from The Atlantic talking about thinking of another game, the game of a stag hunt, to model climate change instead of the prisoner's dilemma, but that's beyond the scope and purview of this class. It's just purely your interest if you want to check it out. I would also argue, though, that there are ways to solve the prisoner's dilemma. It usually requires, altering the payoffs or changing or developing institutions that can hold folks to honor their commitments, so on and so forth. Kind of tangential to this story, we could also think about oligopolistic markets, right? OPEC specifically, oil producing and exporting countries, right, which is a type of cartel. It's an institution meant to sort of enforce or to enforce certain types of production quotas, so that way the countries can get a higher price, right, and essentially behave like a monopoly and enjoy monopoly profits and just divide monopoly profits. Right, so there are obviously several oil producing and exporting countries. OPEC is no longer incredibly effective because, again, there's this inherent instability involved, and there's more than just two players in the game. There are several different players in the game. There's new types of technologies that have developed, but OPEC used to be rather a quite effective institution that allowed the members of OPEC, the members of this cartel, to gain monopoly profits and just divide the monopoly profits into underproduce, right, and artificially inflate the price, right, to charge a hefty markup, right? And I can talk about that model later, but I'll just put numbers here. This is from like a textbook, 2644, 32, 24. And then I'm going to say these numbers in the center represent payoffs, right? These are in millions of dollars. These represent Iran can either choose to produce 2 million barrels of oil or 4 million, Iraq 2 million or 4 million, and you can see the payoffs inherent to them. So I want you to take some time, pause this video. I'm going to go ahead and move on, but you can solve this game. This is the type of stuff that you can expect on the AP Microeconomics exam. Try to solve this game. Where are they going to end up? Explain why this is a prisoner's dilemma. Tell me what a Nash equilibrium is, or think about why the solution you arrive at, although suboptimal, is a Nash equilibrium. It's a solution to the game. And then sort of ways in which you can potentially avoid the prisoner's dilemma, right? If you're able to tell yourself a story, you have game theory down. But I want to move on to other types of tools that we've developed in this class, or concepts that we can use to further our understanding of climate change, right? So we talked about public versus private goods, and this kind of also relates to game theory. And we said that there are two different characteristics that go into determining whether a good is a public or a private good, and specifically whether government intervention is potentially needed to produce or regulate that good. And so we said this is not a payoff matrix, right? This is not a game theory type example, right? This is just sort of an organizational tool that I'm using to help us classify types of goods, right? So we said if a good is excludable we said these two qualities matter, and I'm going to use to classify goods into 4 different categories, right? So if a good is excludable, it means you can stop someone from using it, right? So yes or no. And really there's a spectrum because sometimes there's kind of like a gray area. And then if a good is rivalrous, it means one person's use diminishes another person's ability to enjoy it, right? And then I have yes or no. And then this, of course, you know, there's a hefty gray area for this as well. So if goods are both rivalrous and excludable, they're private goods, and they're going to be adequately provided by private markets. So things like t-shirts, right? It's excludable. You can stop me from enjoying a t-shirt, right? I can't just go into Banana Republic and, I mean, I could and take a bunch of t-shirts, but I mean, reasonably you can stop me from enjoying the benefits of a t-shirt. Don't pay, you don't get the service. And then rivalrous, right? If I eat pizza, for example, or like food or clothing, right? My consumption of it stops other people from consuming that same good, right? That's what we mean by rivalrous. If something's not rivalrous, right, my consumption of it doesn't diminishes another person's ability to also enjoy that thing. So stuff like satellite, but satellite is something that can be excludable, right? We have all types of plans that can exclude people from enjoying satellite television, and we classify that as an artificially scarce good. And again, private markets can still, produce reasonable quantities of any good, right? So this is like the domain of private markets. And here, right, we can think about common resources. We talked about the tragedy of commons, which happens in instances where a good is rivalrous, but it's not excludable, right? We can't stop someone from using it, right? And so we looked at the tragedy of commons example of overgrazing, right? A situation in which there's like a common area to, I don't know, farmers that are grazing their cattle on, right? Nobody owns it, and we would expect there would be overconsumption and overgrazing that takes place. It's the tragedy of the commons. And the reason is we can actually think of game theory to help us think about this sort of reasoning about why this takes place, right? There's an incentive to sort of overgraze your cattle, and we arrive at a suboptimal Nash equilibrium. But there are other things that we can associate with commons, right? We can think of like oceans as sort of the global commons, right? They're hard to exclude people from using oceans, but one person's use diminishes another person's ability to enjoy. And so specifically clean oceans, right? All these countries are incentivized, or not incentivized, but all these countries are, it's hard to exclude countries from using ocean water, and they're dumping perhaps sludge in the ocean water. And so there's a tragedy of the commons example, right? The tragedy of the commons example, we can use the game theoretic concept of prisoner's dilemma to think about the tragedy of the commons example. And so in this column right here, where goods are not excludable, those are realms where we expect government intervention to make a significant impact and a difference, right? And this concept is related to externalities, right? There's negative externalities obviously associated with misusing the commons or overusing the commons. So these concepts kind of bleed into one another, and obviously you can use game theory to think about the tragedy of the commons. So these concepts can kind of bleed into one another, but try to keep them separate and then mesh them together in your analysis for So try to keep them separate and then mesh them together. Like that's the art of being super incredibly smart and knowledgeable, is this ability to think of tools as tools and then use them together, right, to create a project in perhaps different ways, right, in different combinations. But we can also think of climate change as a sort of tragedy of the commons example, expectedly, or the commons being, clean, air, not infiltrated by sort of greenhouse gas. And then finally, excludable goods can stop someone from using it. And then rivalrous goods, one person's use diminishes another person's ability to enjoy it. Goods that are examples of this would be are classified as public goods. So an example of this would be like national defense is an example of a public good. You can't stop someone from enjoying national defense, and you cannot stop someone from or your consumption of national defense doesn't diminish another person's ability to enjoy national defense. And so public goods are underproduced by private markets expectedly, and there's roles for governments to provide public goods, right, expectedly. But obviously for this example, right, climate change, this topic, we're sticking mainly in this quadrant. Okay, so let's think of some policy solutions to climate change, and we have another potential policy solution to climate change. So tax incidence, who bears the burden of the tax? I'm sorry, I'm just so off right now because I have a million things that I need to do. But I talked about a little bit at the beginning, right? I said that one way to sort of push this private marginal cost curve towards the social marginal cost curve is through taxation, right? So let's think about this policy solution a little bit more in depth and sort of the implications of this policy solution on both producers and consumers. And so we developed out this idea of tax incidence, right? Who bears the burden of the tax, right? In Unit 2, right? We wanted to learn about the welfare effects of taxes in Unit 2, and I think Unit 2, you guys really got down. Unit 3 is where for a lot of us things started going downhill, but I'm going to show us how we can, again, sort of integrate all of these concepts to tell a sophisticated story. So potentially one solution would be a per unit tax on gas, right? Gas consumption or gas production. And sort of the novel big idea that we developed in Unit 2 was it doesn't matter if you force consumers to pay the tax or if you force producers to pay the tax, that has no bearing on who actually pays the tax. Right, and to sort of prove this to you, and this is the model that we use to develop this idea, and we're assuming no externality for now. We took out the externality just so it doesn't complicate our analysis. So we're assuming perfect competition, right? And there's no externality that we can see present, but we can think of levying perhaps a 50% unit tax, a per unit tax on gasoline, right, on producers, right? And what this would effectively do, and the way that we model this, is that we shift the supply curve up, right, up 50 cents. And what we see expectedly is that it doesn't matter if producers are the one that take this to the bank, right? Who bears the burden of the tax is determined by the elasticities, the sensitivity of price, or the sensitivity of, for instance, the sensitivity of something to change, and in this case, change in price of the demand curve and the supply curve, right? And so we can see, right, if we shift the supply curve to the left up by 50 cents, right, what we get the way that we model this is we shift the supply curve up by 50 cents, right? And so what essentially we're showing, right, by shifting the supply curve up by 50 cents, let me erase this, is we're showing that there is now a gap. There's a gap between the price that there's a wedge, right? There's a wedge between there's a tax wedge, and a tax wedge is essentially a situation in which there's a difference between, or is the difference between the tax including the price and then the tax after the price, right? And so we shift the supply curve up by 50 cents, and then we can sort of see the effects, right? We can see that this $1.30, right? This is $1.30, and this $1.80, right? Wait, hold on, what am I doing? Yeah. Oh, okay. So we can see that producers don't pay all the 50 cents, right? They can pass on some of the tax onto consumers, right? And we can see that they passed on 30 cents of the tax onto consumers, right? And then this 20-cent burden is actually the actual burden that consumers or producers feel, right? So we can see it doesn't matter that we say, hey, we're going to tax these gasoline companies a per unit tax. What we end up getting is this shaded area, this tax revenue, this sort of burden of the tax is not borne just by producers. Right? So this green area is going to represent tax revenue that we're going to get, right? We can see sort of this tax revenue, right? We can also see that the actual tax itself leads to less production and consumption of the good, right? So we're at Q3, so specifically 90 billions or 90 billion gallons of gasoline is produced. And then we can think about the effects on consumer and producer surplus, right? Consumer and producer surplus. This is going to be consumer surplus now, and then producer surplus after the tax, right? So we can use that tool of consumer and producer surplus to think about the welfare effects of taxation. This green area is going to represent tax revenue, which we can still think of as social surplus, but we end up, because we essentially throw a gap. What would be the appropriate term? Because of this tax wedge, I suppose. Sorry, I'm just trying to find a good way to sort of explain this. Because of this tax wedge, we're distorting incentives, right? Because consumers don't feel like they're paying $1.30. They feel like they're paying I don't know how to describe this. Right, because consumers are also paying the tax, right? They're also paying the burden of the no, that's not the right way to explain it. I'm sorry, I'm going to come back to this in class a little bit later. But we can see, like, with the tax, it distorts incentives, right? So this black area becomes deadweight loss. Those are market transactions that, if we left the market alone, would take place, but don't take place, right? So this becomes deadweight loss. But we can also see how this analysis sort of gets complicated a bit, because we know we have an externality involved. And so, you know, in this model that we developed here, we're assuming no externality in perfect competition to sort of think about the effects of taxation and the distortionary effects of taxation. But we actually might be getting rid of deadweight loss if we throw in the externality in here. Okay, so we can see sort of the effects of taxation. And then you can draw consumer and producer surplus before the tax to think about how consumer and producer surplus is altered. But we know for sure, assuming no externality and assuming perfect competition, that social welfare is reduced because of this deadweight loss triangle. Okay, so what does the tax actually do? So let's think of producer theory, which would be unit 3 for a second. And essentially what a per unit tax does, which is the extent of our conversation about taxation in this class, is it shifts the marginal cost curve to the left. Right, so we can think about shifting the marginal cost curve for producing gasoline to the left. Right? That's what it would do, right? And it essentially the reason why the supply curve is upward sloping is because our marginal cost curves in the short run are upward sloping at some point, right? Because of, and then let's think of why our marginal cost curves are upward sloping, because of this phenomenon in the short run of diminishing marginal returns, right? We have diminishing marginal product of labor. With each additional unit of labor you add, the amount of output diminishes, right? So just you can relate all these ideas together to sort of tell a very sophisticated story. And then finally, we're not going to model taxation as a leftward shift of the demand curve, but you could, right? Let's say you could think of like a consumption tax as a leftward shift of the demand curve, and you could see that the consumer and producer burden are the same. Right? Consumer burden is still 30 cents, producer burden is still 20 cents. It doesn't matter who actually deposits the check in the United States Treasury for like the gas tax, right? So we can think of like the burden of taxation as being tied to elasticities, not tied to who actually the government forces to deposit the check, right? And so that brings me to the next point, is who bears the taxes determined by elasticities. And so I'm not going to have a lot of time in this video to talk about elasticities, but generally inelastic parties get stuck with taxes and elastic parties avoid taxes. And I'm going to show this using a perfectly inelastic demand curve and a perfectly elastic demand curve, right? And so we can imagine, for instance, a 50-cent tax of a perfectly inelastic demand curve. This 50-cent tax is going to get passed on, and let's just say it's on suppliers. The suppliers are going to pass that 50-cent tax because they're going to produce the same quantity completely on consumers. Right, so this blue area is going to represent government revenue. Right, suppliers are still going to produce the same amount, and we can see that their producer surplus is going to remain unchanged. Right, so this green area, I'm going to say, oh, I messed up. Everything above the supply curve, below the price. This is going to be producer surplus both before and after the tax. Consumer surplus is changed. Right, now it's all this yellow area when it used to be all the blue area too.